Welcome to my channel. Today we are going to discuss a very beautiful problem in mathematics. X to power y equals y to power x. Of course, we don't consider hot x equal y cases, and those if x equal y, there's nothing to solve, right? And of course, x and y are not equal 0 because 0 to power 0 we are not defined. Okay, actually we know one solution for this. Let's say 2 to power 4 equals 16, and we know that 4 squared equal also 16, right? So we can write 2 to 4 equal 4 to 2, right? But this is the only one solution, right? This is only one, but there's a lot more. Okay, we are going to find the all infinite solutions for that relation. Okay, right. Now take a look. In here we consider x as 2 and y as 4, right? You can see x is here, y is here, and y is here, x is here, right? As we see, y can be written as something times x, right? This something can be denoted in parameter. I say lambda, right? So I get y equals lambda into x, and what is that? Lambda is a parameter, and also lambda is not equal to 1 because lambda, when lambda equals 1, then it becomes x equals y. So we don't do that here, right? Right. Okay, let's see. Let's plug into these values to this given relation. Given that x equals y equals y equal x, right? Let's plug in our values. X, y is actually lambda x. Lambda times x equals lambda times x equal into x. Right. Finally, somehow I want to end up with a relation between lambda and x and lambda and y, right? Let's continue. If I take lambda x and lambda x to power x, right, I take 1 of x power in both sides, right? Then this lambda cancel out. X lambda equals lambda x, right? We can both divide by x. Finally we end up with x lambda minus 1 equals lambda. Let's get 1 over lambda minus 1 power. Finally we got x equals 1 over lambda minus 1 power, right? Of course y is lambda into x. X is lambda, that is lambda 1 over lambda plus 1, right? Becomes plus 1 minus 1 are cancelled out. Lambda to power lambda over lambda minus 1, and this is y. So we have two solutions for this. X is lambda to the power 1 over lambda minus 1. Y is lambda to the power lambda over lambda minus 1. In both cases, lambda is not equal to 1, right? Those are the solutions. Lambda is a parameter. If we put values for lambda, we can obtain the values for x and y. Okay, let's see. Let's check out, right? I'll put this area for that calculation. Let's say lambda equals to x is 2 to power 1 over 2 minus 1. That means 2 to power 1 equals 2. Y is 2 to power 2 over 2 minus 1, 2 to power 4. right? Also we know that y to power x, right? X means 2 to power 4 to power 2, right? We also know this is correct, right? If we put lambda equals 3, 1 over 3 minus 1, 3 to power half means square root of 3. Y 3 minus 1 means that means 3 to power 3 means 27, square root of 27, right? Finally we got square root of 3 to power square root of 27 minus equals square root of 27 to power square root of 3 equals, right? You can check is this correct by using 1 to m alpha or something you want, right? Please enter square root of 3 to power square root of 27 minus square root of 27 minus square root of 3 and check the answer is, if the answer is 0, then we are correct. But check this out, right? Here's the fun part. Okay, let's put lambda equals minus 1, right? Lambda equals minus 1. So x becomes minus 1. 1 minus 1 minus 1, that means minus 1 to minus 1 over 2. That means 1 over I, right? 1 over I. Okay. Y becomes minus 1, minus 1 to power minus 1 minus 1, minus 1 to power half, that means I, right? Okay, actually we can solve this other steps. We can both multiply numerator and denominator by I and it becomes minus I, right? So if we plug in those relations to that our given expression, right, we can obtain minus I to power I minus I to power minus I equals 0, right? Yeah, it's very beautiful, right? Actually we can check is this correct. Okay, I put another sheet. Okay, here's our result. Okay, let's check it is okay, right? Minus 1 to power I minus I to power minus I. Okay, here's our complex plane. Real axis 0, imaginary axis, and there's I, there's minus I. Okay, minus I can be written as e to power this negative angle minus I 5 over 2 to power I minus I 5 over 2 into power I. Okay, there's minus I squared 5 over 2 minus I'm sorry, yes, minus I, right? Minus I squared 5 over 2. Also these are so we can see these terms are equal, right? But I squared is minus 1, so there's 5 over 2 minus e to power 5 over 2. Actually this is 0. So we are correct, right? So finally let's group our results. X to power y equals y to power x. Of course x and y are not equal, x, y are not equal to 0, right? Result is x, y. Let's say x is lambda into lambda to power 1 over lambda minus 1, lambda to power lambda over lambda minus 1, lambda not equal to 1, and lambda is a parameter, right? There are infinitely many solutions for these given expressions, right? Okay, that's it.